What's going on, guys? In this video we are going to see how to find unknown voltages using nodal analysis by inspection method. Now in order to do this method we have to follow all these 6 steps. Let's go by one by one. The first step is find a reference node with known voltage. Now for this part what we do is we connect this bottom part to the ground. In that way we will have a 0 voltage right here, and that's going to be our known voltage. And then the second part is assign voltage to the other nodes. Now if you look at this one, other than this node we have two other nodes. So for these two nodes we are going to put V1 and V2, right? And after that what we have to do is assign conductance to resistor. Conductance is basically 1 over resistance, and wherever we have resistance we are going to put conductance. And here we have 2 ohm, so the conductance is going to be 1 over 2. And here we have 5 ohm, so the conductance is going to be 1 over 5. Here we have 4 ohm, so the conductance is going to be 1 over 4. And that's it. Those are the resistance we have. The next step is find the elements of the conductance matrix for each node G, whatever the matrix location is. So here what we are going to do is, for example, if you want to find G11, what you have to do is you have to look at the conductance that is connected with this voltage 1. And here we have two conductance that is connected with this voltage 1, that is 1 over 2 and 1 over 5. So we add them together. So this is going to be 1 over 2 plus 1 over 5. And here we can take 10 as our common denominator. If we take 10 as our common denominator, this is going to be 5 plus 2 on top, and that's going to be equal to 7 over 10, and that is equal to 0.7. And then we have to find G22. Since we have two voltages, we have to find G22. Now to find G22, again same process, we have to look at the conductance that's connected with this V2 and add them together. And here we have 1 over 4 is connected with this V2. Also this 1 over 2 is connected with V2, so we add both of them. So this is going to be 1 over 4 plus 1 over 2. Here we can take 4 as our common denominator. If we take 4 common denominator, this is going to be 1 plus 2 on top. So this is going to be 3 over 4, and that's going to be equal to 0.75. And the next step is between each two nodes. Now we have found out the conductances for each nodes, and now we had to find between this V1 and V2. And between this V1 and V2 we have only one conductance is connected, that is 1 over 2. So G12 is going to be equal to 1 over 2. But here's the main thing. Here one more thing we have to do. We have to put a negative sign. This is only for this process, the between each two nodes, right? So this is going to be equal to negative 0.5, and this is also going to be in G21. And that's it. After that, set up the node equations in matrix form. So how do we set up is like this. We arrange this G11, G22 in diagonal, like 0.7 in this side and 0.75 in this side. And after that, G12 and G21 is going to be in the other side, like negative 0.5, negative 0.5. That's why we put this one. G11 represents first column, first row, first column. This G22 second row, second column. First row, second column, second row, first column. If you study linear algebra, you know what I'm talking about, right? And this is what we get. And then using this one we had to find the voltages. Now here we are going to use Cramer's rules. Cramer's rules, if you remember that we have to find determinant, and then we have to find the original determinant, then we have to swap these values. So here we are going to have minus 6 and also 8. How did I get this value? Then I'll show you. So here what we have to do is we have to look at the current sources. So first voltage, if you look at the first voltage, here we have 6 ampere is going out of this voltage, so that's why I put negative 6 right here. And if you look at the second voltage, we have two current sources entering this voltage, like 6 ampere is entering 2 ampere is entering, so both of them together 8 ampere. So that's why we put minus 6, 8. So that's the value we have to put in the other side. Now we are going to use the Cramer's rule. Cramer's rule is we have to find the determinant of this original form, and after that we have to swap with this one and find the determinant, and swap with this one and find the determinant, and then use the Cramer's rule, right? So here let's find this original determinant, and determinant is AD minus BC. If you remember, ABCD, this is the pattern, and AD minus BC is going to be the determinant. AD minus BC. Now let's arrange them. We have 0.7 minus 0.5 minus 0.5 0.75, and if you do the AD minus BC, we will get 0.275. So that's going to be our main determinant. Now if you find the determinant after swapping with this one, like let's swap this one first. So if you swap with this first column, you're going to have minus 6, 8, and the other side you're going to have minus 0.5, 0.75, and now if you do the determinant, you're going to have negative 0.5. Now if you do it for the 2, now what we are going to do is we are going to swap with the second column and find the determinant. So if you swap with the second column, we are going to have 0.7 minus 0.5. The first column remains the same. Second column is going to become minus 6, 8, and now again if you do the AD minus BC, you will get 2.6, yeah, 2.6. Then after we find the determinant, we have to use the Cramer's rule. To find the V1, what we do is we put the first value, whatever the value we found from swapping with the first column, and divide by the determinant, and that's going to be what, negative 0.5 divided by 0.275, and that's going to give us negative 1 point, it should be negative, right? So here we're going to have negative 1.818 voltage. So this is our V1. V2 is going to be this second one. We found out this is equal to 2.6. This is equal to 2.6. Now 2.6 second value, whatever the determinant we found, divided by the determinant. So that's going to be 2.6 divided by 0.275, and that's going to be equivalent to 9.455 voltage. Now we have found out the two unknown voltages. Now in case if you want to find a current, let's say you want to find a current going through this, let's say this is I4 going through this, you want to find the value. Now to find this one, we know that current is equal to voltage drop over resistance. So here the voltage drop is going to be what? It's starting from V2 minus 0. So V2 minus 0 divided by 4, and we know the V2 is equal to 9.455 divided by 4, and that's going to be equivalent to 2.36 ampere. So that's going to be the current that's going to go through this way, and the direction is also right because we are getting a positive answer. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.